Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 6, Section 5, Indirect Proofs and Inequalities in One Triangle. So far, we've been doing proofs in the direct method. So a direct proof works this way. We start out with some kind of hypothesis, if part, and we say that that's true. And then we build some kind of logical argument until finally we come up with a conclusion, and that's the then part. So that's how we would do a direct proof. It seems pretty reasonable. But there's another way that you can do proofs. It's called the indirect proof, or proof by contradiction. And this adds one more step. So we have identify the conjecture, use logical arguments to come up with some kind of conclusion, and then you can conclude the conjecture is true. But the part that is different here is the second part. We assume the conclusion is false, which is kind of odd, but in a lot of cases it works out much better when you're trying to prove certain things, because sometimes trying to prove what it is not, or the opposite, is easier than proving something directly is true. So let's give an example. We have a triangle, and we want to show that triangles cannot have two obtuse angles. And it makes sense, right? If you have obtuse angles, then the obtuse angle has to be greater than 90 degrees, and if you have two of them, well then you have more than what the triangle sum theorem allows you to have. So the first thing we do is identify the conjecture to be proven. If it is a triangle, then it cannot have two obtuse angles. What we're going to do with the second one, and this is the different part, is that we're going to assume the opposite conclusion is true. Assume temporarily that if we have a triangle, then it can have two obtuse angles. Then the third thing we do is now we use direct reasoning until we hit our head or show there's a contradiction. So assume temporarily that the triangle has two obtuse angles. The measure of any obtuse angle is greater than 90 degrees. So the sum of two angles is greater than 180 degrees. But that's a contradiction to the triangle sum theorem. So my assumption in number 2 is false. And because of that, I can conclude that my original conjecture is true. So my assumption is false. A triangle cannot have two obtuse angles. Therefore, my original conjecture is true. And this is the formula that we always use. Number 1, identify the conjecture. Number 2, assume the negation of the conclusion. So you say, if I have a triangle, then this cannot be true. Use direct reasoning until we hit a contradiction. And then finally conclude that since we have this contradiction, then our original statement must be true. And we'll continue this conversation in the next video.